Express z to the 5 minus 4z to the 4 plus 5z cubed minus 6z plus 4 as a product of linear factors. So we're going to use the factor theorem here. F of z is z to the 5 minus 4z to the 4 plus 5z cubed minus 6z plus 4. Now really, I need to try to find 3 linear factors. So let's start with, we've got a 4 at this end, so 1, 2 and 4, plus or minus all of those things I need to consider. So f of 1 is 1 take away 4 plus 5, take away 6, add 4. So that does come to 0. So that tells me that z minus 1 is a factor. What about f of negative 1? That's going to be negative 1, take 4, take 5, plus 6, plus 4. And that also is equal to 0. So z plus 1 is a factor. What about f of 2? So that would give me 32, take away 64, plus 5 times 8, which is 40, take away 12 plus 4. What does that come to? So we've got 32, take away 64, add 40, take away 12, add 4, and that's 0 as well. And that means that z minus 2 is a factor. And that means that z minus 1, z plus 1, z minus 2 is a factor. So that's z minus 1, z squared minus z minus 2, which is z cubed minus z squared minus 2z, take away z squared plus z plus 2 is z cubed minus 2z squared minus z plus 2. So we can say that z to the 5 minus 4z to the 4 plus 5z cubed minus 6z plus 4 is equal to z cubed minus 2z squared, take away z plus 2, multiplied by a quadratic factor. With a z cubed here and a z to the 5 there, it must start with z squared. With a plus 4 here and a plus 2 here, it must finish with plus 2, and we're not sure what goes in the middle. But we could use coefficients of, say, z to the 4 to find out. So here, the coefficient of z to the 4 is negative 4. What's going to give me a z to the 4 on the other side? Well, certainly that will, and it will give me negative 2. And also that will, and that will give me plus a. And that gives me that a equals negative 2. So what we have so far is z minus 1, z plus 1, z minus 2, and then our quadratic z squared minus 2z plus 2. I can't see any obvious way of factorising that quadratic. So we could try something like completing the square or use the formula. Let's try completing the square. So I've got z squared minus 2z plus 2. Let's just underline this line because we want to come back to this. So that would be z take away 1 all squared. Now remember, that would give me z squared minus 2z plus 1. So I need to take 1 away, and then I've got this 2 still here. So that is z minus 1 all squared plus 1. Can we factorize that? Well, we can. What we could do, just think about this for a second. If we had something like z squared minus 1, we know that that's z minus 1, z plus 1, just a difference of squares. If we had z squared plus 1, now that we know about complex numbers, we can make that into z minus I and z plus I. So this one here is z minus 1 minus I and z minus 1 plus I. So we could write that as z minus 1 plus I and z minus 1 take I. So our linear factors are, going back to the line star, which is just at the top of the video there, that is going to be z minus 1, z plus 1, z minus 2, z take away 1 plus I, and z take away 1 minus I. And note, if we were solving this, we'd end up with 3, solving it equal to 0, obviously, we'd end up with 3 real numbers, 1, -1, and 2, and a complex conjugate pair.